Hello. So today we solve moving charge and magnetism, some numerical problem. Here the 10 best numerical on CBSE or not, sorry, I see that here ISC board. Okay, mainly important in board exam and also the basic of JEE and NEET preparation. Okay, you know the formula, you can apply that here and you get a final answer. Okay, so here this is also a recap of all these portion we discuss here. Okay, all moving charge and magnetism portion discuss here. There's something on you can call a recall lecture also on solving numerical. Okay, so here that question number 1, the force on moving charge and magnetic field. One thing is very important. If you want to clear the concept or remember the concept and such a long period of time, you think that is a remember. So you solving some numerical. Okay, if you solve the more number of numerical, so that's why the easiest way to remember the all formulas. Okay, and all some basic concept. What is Bauer's law and what is Ampere's law? So that's why you solving numerical. Some after 1 month's gap, you solving same numerical or same chapter numerical. Yeah, you can use the from ChatGPT, DeepSeek, or your basic NCERT books or any other books. Okay, FC1 books. So solving some numerical and take some little gap. To practice gap is very little. If you practice gap is very small, means if you practice in first of the month and the next same type of some type of problem solver in the same chapter in next month in same time first week of next month. Okay, that's why easiest way to remember the all formula. Okay, so here we solve the first formula here, some like a first chapter, first question here, not first chapter obviously. That is a chapter number, I think, chapter number 4. Okay, so force on a moving charge and magnetic field. So given question here, an alpha particle of charge Q 3.2 into 10 to the power minus 19 coulomb enters a magnetic field of flux density B, that is 0.2 Tesla, with a velocity V 5 into 10 to the power 5 meter per second perpendicular to the field. So perpendicular means you know that is theta, that is equal to 90. Okay, find the force on it and radius of the circular path. So you can first find the force, then radius of the circular path. Also force, we know that is get question, that is force, that is Q V cross B is V, and you know that is angle with a 90 degree perpendicular. So Q V B sine 90 degree and sine 90 be the 1, so you get QVB. Okay, so Q is given here, the charge Q, that is 3.2 into 10 to the power minus 19. So velocity given here 5 into 10 to the power 5. B, that is 0.2 Tesla. And one thing is, remember, in CBSE board calculator is not allowed. Okay, but ISC or I think may some state board allow in calculator, but here the CBSE is not allowed, but ICSE allow. Okay, in just remember one thing. Okay, so in the CBSE student, please do that some numerical practice, some calculation. Okay, and in get exam you get a calculation, very not a difficult calculator, but not a decimal place calculation are given. Okay, there are basic some calculation of digital integer numbers. Okay, given. So but you try to calculate, okay, at your own, but ICSE student, you calculate with the help of calculator. Okay, so calculator allow in ISC. So 32, now remove, that is 10, that is remove 10 here. So 5 to the 10, so 2 will the cancel here. So finally you get 32 into 32 into 10 to the power 19. Here this 1, 10 to the power minus 1 and 10 to the power 5. So that is calculated 19 plus 1, 20, 20 means 32 into 10 to the power minus 15. So SI unit of force is Newton. The first answer. And second answer is a radius. Second answer is the radius of the circular path. So the R now, R equal to mv by qb. Okay. So now put the value of m here. So mass is given. So mass of alpha particle is given here 6.64. 64 into 10 to the power minus 27. Velocity is given here 5 into 10 to the power 5 by Q. Charge 3.2 into 10 to the power minus 19 and B 0.2 Tesla. Okay, first you remove the odd points. Okay, remove points here, get 100, 32, get 10, 0.2, get 10 here. These 100 cancel. Okay, so now 2 cut here 332. Okay, and now 332 by 32. Okay, that is 10 to the power minus 27 or 25 gets 10 to the minus 22. Down is denominator is 10 to the minus 19, so that is 10 to the power, this is 51, 10 to the power minus 3. Okay, so here 5 into 332, 332, so here is 1660 by 32 into 10 to the power 3 minus 3 obviously, and that is given here, that is 16, and that is get 830. So you get 83 by 16 and get 10 to the power 1 or get minus 2, not minus here. So 16 times 16, 83 divided by 16, 16 5s 80, 30, almost approx 5.2 into 10 to the power minus 2 meter. Okay, that's the answer. Second answer, radius of the circular path. Now, next question. Velocity selector crossed E and B field. Okay, so an electron moves in a region where the electric field is 3 into 10 to the power 4 volt per meter and the magnetic field is 2 into 10 to the power minus 3 Tesla, means 2 millitesla are perpendicular to each other. So find the velocity and of the electron, so that is passes undeviated. Okay, and you know that the formula velocity equal to E by V. Okay, we know that. We discussion how to calculate velocity selector in theory lecture. And see the lecture, I did lecture in link in I button. Okay, see the lecture how to find the velocity selector. Okay, the topic. So electric field 3 into 10 to the power 4 by 2 magnetic field here 2 into 10 to the power minus 3. So here is 1.5 into 10 to the power minus 7 meter per second. That is the correct answer. Now question number 3. Force between two parallel currents. The two long parallel wires are separated by a distance 0.2 meter. They carry currents of 10 ampere and 15 ampere in the same direction. Find the force per unit length between them. Okay, we know that how to solve that and discuss also theoretical theory. How to, what is the force dependent to parallel current. Both are in same direction or opposite direction. There is a force. We know that, but here it is calculate only force per unit length. Force per unit length actually. So we get force. So we know that direct formula mu 0 by 2 pi. That is distance means d mu 0 I A, I, B, two currents. Okay, so actually formula is force equal to mu 0 2 pi d IA IB times L. So force per unit length is force by L. Remember that's the not force. Calculate force per unit length. So the SI unit is Newton per meter. Remember, okay. So mu 0 that is equal to 4 pi into 10 to the power minus 7. You know the mu 0. IA 10 ampere and 15 ampere. 10 times 15 by 2 pi d. Separation is 0.2 meter. 0.2. Okay. So here now the calculation is remove the point first with 10 here. 10 to 10 here. Next the pi be the cancel. So 2 cancel. 15. There is a 210 here. 10 into 10 to the power 7 and this to 10 to the 5. So 10 to the power minus 5. Okay, that is Newton per meter. Okay, so that's question number 3. The force per unit length. That's the answer. Now the next question, question number 4. The magnetic force on a current carrying conductor. A straight conductor of length is 0.5 meter carries a current of 3 ampere and is placed in a uniform magnetic field of a 0.4 Tesla. The conductor makes an angle of 30 degree with the field. Find the force on the conductor. Okay. So first magnetic force of current carrying conductor. Okay, the state conductor 0.5 meter carries a current 0.3 ampere, placed a uniform magnetic field 0.4 Tesla. Find the force on the conductor. Okay, that is force, that is QVB, and another formula is IDL cross B. Okay, so here we use this because there is a current. Obviously, place I is 3. Suppose there is integration here, so get A and IL cross B. Okay, so IL given length is 0.5 and B magnetic field 0.4 Tesla. The angle between these two is sine, obviously sine 30 degree. So 3 times 5 times 4 by 100, that is sine 31 by 2, that is 2 to cancel. So here that is 5 to the 10, so 1 0 cancel, 0.3. 0.3 here, that is a 0.3 Newton. Okay, now question number 5. A cyclotron problem. Proton is accelerated in a cyclotron using a magnetic field is 0.8 Tesla with the radius of the path is 0.5 meter. Find the frequency revolution and the kinetic energy of proton. So the kinetic energy K, that is we know that is half mv square, and that is V. We find the V from here, that is QBR by M, and QBR by M. So final expression is that half M, that is Q square B square R square by M square. Now this cancel. Half Q is given here 1.6 into 10 to the power minus 19 coulomb. Magnetic field is 0.8 Tesla and the radius Obviously these are the square. R also given 0.5 meter, also that is a square, by M 1.67 into 10 to the power minus 27. Okay, so kinetic energy to SI unit is a joule. And now solving these is with the help of calculator. Okay, and put here as a joule. I solve this with the help of calculator. I put here, and you solve this. That is a homework problem. You solve this and put in comment section what answer you get. Okay, that question number 5. So actually the answer you get we get 1.53 into 10 to the power minus 12. Do it yourself, okay, and put in comment section what answer you get. Now next question, question number 6. Find the magnetic dipole moment of a current loop of given radius is 0.05 100 turns and carries a current is 2 ampere. Find the magnetic dipole moment of the coil and magnetic field at the center. Okay, that you know that easy. First, the magnetic dipole moment. We know that magnetic dipole moment that is mu, that is NIA. Number of turn here is 100. Current is 2 ampere, and that is circular coil. So radius is given pi r square 0.05 whole square, and that is 100 into 2 into pi is 3.14. So 0.05 means 25. 25 by 100 times 100. This 200 will cancel. 25 times 4 to 2, and you get 3.14 gets 1.57. So mu, unit of SI unit of the mu is I ampere meter square. Okay, that's a SI unit. Next, magnetic field at the center. So magnetic field at the center, that is equal to B that is equal to mu 0 n I by 2r. That's the formula. Okay, that's the formula to find the magnetic field at the center. Okay, we solve this in Biot-Savart's law application. Okay, we solve this type of equation, derive these types of equation. Okay, from with the help of Biot-Savart's law or from Biot-Savart's law. Mu 0, that is 4 pi into 10 to the power minus 7. Number of turns with 100. Current with 2 ampere. To radius is given 0.05. Okay, so now solve these. Solve this. So 4 into 3.14 into 100 into 2 into 10 to the power minus 7. So 2, 0.5 is 5. Here is 100 again. Okay. So now 5 to the 10 and some 1 0 with a cancel. 4 into 3.14. Again, if I remove this by 100, so times 10 times 2 into 10 to the minus 7 times 100. These 200 will cancel here. I jump from here. Okay, so 4 into 3.14, 4 into 314, sorry, not 3.14, times 2, 10 to the power minus 6. So you get 4, so 3.2 is equal to 6 to 8 times 4 into 10 to the power minus 6. That B, so that's Tesla. Okay, and numbers you get that is if I multiply 4 to 32 carry 1 I shall carry 3 4 32 2 3 4 to the 8 8 plus 3 11 1 carry 1 4 6 the 24 plus 1 25. So if I 1 2 3 point shift here into 10 to the power minus 3, so I get 2.512 millitesla. Okay. Number 7, deflection of an electron in a magnetic field. That's very important. An electron moving in 3 into 10 to the power 6 meter per second enter a uniform magnetic field is given 0.01 Tesla at 90 degree to the field. Find the radius of circular path and time period of revolution. Okay. So here is given. So first find that is radius of the circular path. That is, we know that r equal to mv by qb. We know that of solving from first numerical. Okay, with help of solving this first numerical with the help of this equation. So here that m is given, mass of electron 9.1 into 10 to the power minus 31 kg. Velocity is uh, 3 into 10 to the power 6 by charge q 1.6 into 10 to the power minus 19 and magnetic field is 0.01 Tesla. Now we remove the point here, get 10. Okay, now the point is 10 here with a 100. So 10 with a cancel. Okay, so you finally get 91 into 3 by 16. So you 10 to the minus 31, 10 to the power minus 31, and that is 6 plus 2, 8. 8 10 to the power 8, 10 to the power 19. So you get 3 to 7 by 16. So you get 10 to the power minus 31 plus 8 and my 1927, and that is a plus 27. So you get a minus 4 here. So 273 by 16. You get 10 to the power minus 4, and that is 16 ones are 16. So 11 3 16 6 7, 16 sevens are 112. So get 112. So you get 1. So 1 is not get here, and get 6 into 10 to the power minus 4. So if I shift, okay, and you get almost 17 into 10 to the power minus 4. Okay, that is a meter. Now what is the time period of the revolution? Time period is a t, that is equal to 2 pi r by v. Okay, so here 2 pi r is given here. 2 pi is 3.14, r is 17 into 10 to the power minus 4, divided by v is given here, velocity 3 into 10 to the power 6. Okay, and you get the time period. Okay, you solve this with the help of calculator. Time period in second. Otherwise you can do it some basic step here. Something now r is replaced by this, so that is t equal to, so t equal to 2 pi r is mv by qb by v, and v cancel. So 2 pi m by qb. Okay, that's also the formula you can solve this. Okay, Same formula here. You can put the data, all data here, and you get the time 20 seconds. I will do it with the help of calculator and put that question number 7 answer in comment section. I will check the all answers. Okay, you do it in your homework problem and solve this with the help of calculator. Otherwise, you can do it your own and you put the answer in comment section. Okay, that's the homework problem. Now the question number 8. A rectangular coil of dimension is given, that is 0.1 meter, 0.05 meter, has a 50 turns, carries a current of 3 ampere. It's placed in a magnetic field is 0.2 Tesla, making an angle is 30 degree. Find the torque acting on the coil. Okay, from moving coil and galvanometer, tau, that is N, that's the N, the number of turn, I, current, area, cross section area, B, sin theta. So here that N is given 50 turns, current is given 3 ampere, the cross section area 0.1 times 0.05, okay, and the magnetic field is given here 0.2 Tesla, okay, and sin theta is 1 by 2. So first remove the all decimal place value here, tens, and that is 2 will be the cancel here, okay, and just here 0, this 0 will be the cancel, okay, so 5 2s are 10 here, these 2 is not cancel here, there's 2 here, so 5 3 is a 15, okay, 15 by 2, this 100 is 10 to the power minus 2, okay, that is get 7.5 torque into 10 to the power minus 2 Newton meter. Okay, so you change that 0.2, so decimal place also left side. Okay, that is applicative height. Now we're solving this and that is solved here. Okay. Number 9. A long straight wire carries a current of 10 ampere. Calculate the magnetic field at a distance of 0.5 ampere from the wire. Okay, and we know the formula from Biot application, B equal to mu 0 I by 2 pi r. So here that is mu is given 4 pi into 10 to the power minus 7, that is current is given 10 ampere, magnetic field at a distance 2 pi, r is 0.5, the 10 here, pi cancel, 2 4 2, 5 2 the 10, so get 4 into 10 to the power minus 6 magnetic field with a Tesla. So get a 4 micro Tesla, 4 micro Tesla. A very small number. Okay, 4 micro Tesla, because Tesla is a very large. Number 10, ampere solenoid. So a solenoid has a 500 turns of length of 0.25 meter, carries a current of 4 ampere. Find the magnetic field inside the solenoid. So that's the basic ampere law here. So B equal to mu 0 n I by length. So mu 0, that is 4 pi into 10 to the power minus 7. Number of turns is 500 and current is 4 ampere by length is 0.25, 100, so 25, 5 100, 5 here, 5, that is 20, 20 times 4 is 80, 80 into 4, 320, 320 pi, okay, and into 10 to the power minus 5, Also get 32 pi 10 to the power minus 4 Tesla, and put the value of pi here, you get the answer. 32 pi 3.14 into 10 to the power minus 4 Tesla. Okay, that's the basic 10 numerical, very important in boards exam, also JEE and NEET exam. And solving the numerical, okay, if you have any doubt of any type of numerical, take the picture and put in comment section. Okay, I'll try to give the answer, all numericals, if you have any doubt in any portion. Okay, so next class we discuss the new chapter, new concept today in the class here. Thank you.